Hi, we're here today in the Covec lab. We're here with Chris from D-Star Racewear, a racing suit manufacturer. Over a year ago we were commissioned by the FIM to look at materials and material performance and to prevent heat transfer, heat friction from flat track and motocross race scenario crashes. So today we kind of did we did some basic analysis of materials that have been used. We've got some of those materials here today, and what we're going to do is we're going to put a soldering iron. It's a really Neanderthal test, but it'll give you a good indication of how good Covec is protecting against heat injury. In the first instance, we've got polyesters that are widely used in the suit manufacture. And then we have polyester that's backed with an aramid. Lastly, we'll show a typical cool mesh t-shirt, which is used for sportswear for wicking away sweat, typically used as well for encasing armors that are used in the undersuit. I think you'll find this quite interesting. Chris, do you want to put on the first polyester? So actually that's Keprotec. Get a new assistant. So all we're going to do, so that we can show that we're not applying any less or more pressure, we're just going to lay the iron straight onto the polyester for a short period of time. Do you want to stick that on there, Chris? So effectively you can see it's smouldering already, and this is one of the materials used in the suit. And within a very short space of time it's gone straight through the polyester and also burnt the cardboard underneath. So you can assume it's safe to say that's your arm and that's your skin. We have a different grade of polyester now, one that's widely used, the patterns and colours specifically in speedway racing. So we'll do the same thing again. We're just going to place it on there and leave it on there for, again, a short space of time. And as you can see, smouldering nicely again. Do you want to take it off, Chris? You can see it's gone straight through. It's melted to the box, and that's kind of in less than 5 seconds. Now, the heat, the temperature, is similar to that you can generate in friction crash, whether it's on the road or on the track. The engine exhaust pipe, they can line you for a considerable amount of time, so either of those scenarios could possibly create massive skin burns. We're now going to do the same test with a piece of aramid backed polyester. So it's a hybrid material, one typically used for the performance of the aramid, given the flexibility of the polyester on top. So if we leave it for a similar amount of time as we did with the other two basic polyesters, we'll take that off the box and you'll see the aramid has melted to the box. And it's gone straight through the whole thing. So again, short space of time, and the net result is a burn. So we're now going to try it with a very well-known brand, Swiss brand. It uses Kevlar on the back of it, and it's a Schuella product. Again, we're going to put the soldering iron on it. This will do something different. It's a well-made product, and putting it on there for a similar amount of time, it will show different tendencies than the other materials, but the one thing that's clear is that the material on top has actually melted. It's gone straight through to the skin in a short space of time. Now the reason for that isn't so much that the aramid Kevlar used in it is responsible. There's just a very small amount of Kevlar used in that material. So it's predominantly polyester or nylon, and it predominantly is used for exterior appearance with a small amount of interior strength. Lastly, we're going to do the material which most people wear right next to the skin to try and keep comfortable, wick away sweat when they're racing, or just base layers that are underneath biking clothing. Now this is, I think this is kind of the scariest of all, because this one here has got the lowest melting point, and it's the one you have closest to your skin. So again, doing it over a similar time with weight on top, it's gone, it's disintegrated, and it's almost burnt a hole through the box, through the cardboard on the bottom as well. So that's pretty scary. Now what's happening there is when you're racing and you are sliding, if it's track based, you're sliding down the track, you will get the same heat, temperature and friction. So it's not actually a lot of the injuries you sustain when it breaks the skin are consequential injuries caused by the sliding against the track. Lastly, we're going to look at the FIM suit. We're calling it the FIM suit at this point in time. We've done the research and development on behalf of them, so we're currently doing trials with riders, and we've had some great feedback. So we're going to basically put the material to the sword, and we're going to see over a similar space of time exactly what it does. So if we go in close, and as close as we can possibly get, you'll see that actually on the same period of time there's almost no fibres have been broken whatsoever. There's material isn't affected at all, and in the interest of science, being the experimental people we are, we're now going to put it onto the sleeve and just see how long it takes to kill it. We could be here sometime, so on that basis we'll give you a quick overview. It's developed and designed particularly for flat track racers. It can be used for any motorcyclist, but it gives you complete flexibility, gives you impact abrasion resistance as good as leather, but on top of that it stops you getting burnt. Everybody's getting bored now. Chris, do you want to take it off? So you see, that has been on a ridiculous amount of time.
It's a bit hot.
It's very hot. That has not burnt through at all. So you want to see what you should be wearing next to your skin when you're racing. It's got to be a Covec suit. Chris, thanks for your help today. I hope anybody's watching's found this entertaining, and we'll catch up with you soon.